قوتابیانی عزیز خۆشەویست دەست دەکەین بە تەواوکردنی chapter 4 لە بابەتی determination of enthalpy of reaction لێرەوە وەستاوین و لێرە دەست پێ دەکەینەوە ئینشاءالله. Enthalpy of reaction delta H, heat of reaction or energy of reaction, okay? These are different names for enthalpy of reaction. Delta H stands for enthalpy of reaction or change in enthalpy, enthalpy change, heat of reaction, energy of reaction. It can be calculated by different ways such as delta HF, enthalpy of formation of substances, Hess's law, and delta HC, enthalpy of combustion. Actually, the first and the second one, they are the major ways, the major techniques to get the value of delta H, and the last one, delta HC, interferes the first point and second point also. Let's start by the first one, determination of delta H using delta HF, enthalpy of formation of substances. We have this rule. According to this rule, we're going to get the value of delta H. Look, first of all, you have to look into into knowns, given, I mean, okay? If we have delta HF of all reaction substances, then you have to use this formula, this equation. Look, sum of delta HF of products times number of mole minus sum of delta HF of reactant times number of the moles. Well, I'll do in my way, I'll do it by myself like Thanos said. Let's see. As we know that delta H equals to enthalpy of product minus enthalpy of reactants. So it's true, same for delta HF also. Delta H equals to delta HF for the product times number of mole minus delta HF of reactants times number of mole. This formula is useful to get delta H when we have delta HF of all substances. Like this. Immediately we have some notes and they must be concerned. The first one, free elements, Na, K, Al, etc., they have zero enthalpy of formation. So delta HF equals to 0 for the following points. The first one, free elements. For the free elements, I mean each individual element in the periodic table, they have zero value of delta HF. Gases such as I2, O2, N2, chlor, fluor, bromine, iodine gas, they have zero value of delta HF, except of I2 sometimes. Look, for the solid I2, delta HF equals to 0, but for the gaseous I2, delta HF equals to 62.43 kilojoule per mole. You don't have to memorize this number. And for carbon, we have two different forms of carbon, graphite and diamond. For graphite, delta HF, it's 0. Well, if we compare graphite to diamond, graphite is useless. That's why we will put 0. This is just, you can use as a trick to memorizing this. Graphite is 0, but for the diamond, it's 1.897 kilojoule per mole. Phosphorus, we have two forms of phosphor, white phosphorus and red phosphorus. For the white phosphorus, it's 0, but for the red phosphorus, it's negative 70.46. Let's solve some question about this. Okay. Remember, we are going to calculate the value of delta H based on delta HF. How do you know? We have to use this formula equation that makes a relationship between delta H and delta HF. Of course, if we focus on the unknown, look, calculate enthalpy of reaction, delta H. Calculate delta H, okay? If we have these informations, look at them. They are delta HF. So we have to make a relation between delta HF and delta H. Okay, mister, it's calculation of delta H using delta HF method. So, first of all, you need to have a general equation. Without general equation, you're gonna be disabled and you can't do anything. So first step, you must to have a general equation, I mean the reaction. If not, you have to write by yourself. How we can write by ourselves? Okay, I have taught you how to write the combustion reaction or the formation reaction. Well, look, calculate delta H, enthalpy of reaction for the combustion of nitrogen monoxide. So we have NO when it combusts. So combustion reaction for any substance, we have to write plus oxygen, nitrogen monoxide gas NO to form nitrogen dioxide gas NO2 to producing NO2. Okay? Remember, you have to balance the equation. You have to balance. Okay, I prefer to rewrite again in a nice way. Okay. We need to get the value of delta H when nitrogen monoxide NO combusts to producing nitrogen dioxide NO2. If we balance, multiply, you don't have to change the coefficient of combustible compound. It must be 1, as I told you. So you have to times 1/2 oxygen. So then we will decrease 2 to 1. Now it's balanced, okay? So we need to get delta HF for this one, and for this one. Look, delta HF of NO times delta HF of NO times number of mole. Number of mole, it's 1. Bracket. Plus, open another bracket. Delta HF of O2 times number of mole, it's 1/2. Here, delta HF of NO2 times number of mole, it's 1. Close the bracket. So these are sum of delta HF of reactants times number of their mole, and this is delta HF of the product. So write the equation formula. Delta H equals to delta HF for the product times number of mole minus delta HF of reactant times number of mole. Okay. Now, these are reactant, it's product. So, delta HF of NO2 times 1 minus product minus reactant, okay? Product minus reactant, just like this. Delta HF of NO times 1 plus, because of delta HF for gases, okay, is 0, so forget about oxygen, so it will be 0, okay? So just like this. Minus delta HF for NO. Delta HF NO times 1. So let's substitute the numbers. If know that delta HF for NO2 is 33.2 and for NO it's 90, So substitute numbers. NO2, it's 33.2 times 1, okay? 33.2 times 90. You see how it's easy? Okay, so it's equal to 57 negative, of course, negative 57.1 kilojoule. So it's delta H for the combustion of nitrogen monoxide in a sufficient amount of oxygen. First step, you have to write the balanced equation, then substitute delta H of for each individual components, then write equation formula and use your calculator. Another one. It's solved by itself, so how I can zoom out? No problem, like this. Okay, it's good. Calculate enthalpy change when 1 mole of C6H12O6 combusts to form CO2 and H2O. As I told you, first step, you have to write the balanced equation. So on what base combustion of C6H12O6 glucose? So if we combust C6H12O6 and given amount of oxygen, it will produce CO2 and H2O. After balancing, you realize that the coefficient of each of them will be 6, right? Then delta H equals to sum of delta HF for the product times number of their mole. Look, delta HF of CO2 times 6, delta HF of H2O times 6, there will be plus sign, okay, minus delta HF for the reactants. Delta HF for C6H12O6 times 1, because of number of mole is 1, and delta HF for O2 times 6, and it's 0, it equals to 0, so we will neglect this. And now substitute numbers, okay, substitute numbers. Delta HF for CO2 is negative 393 times 6. 393 times. Delta HF for H2O times 6 again. H2O negative 286 times 6, okay, minus for glucose negative 1263 times 1. Okay, it's very easy. Just use your calculator. It's for 1 mole, of course. It's for 1 mole. So for 1 mole, this delta H, it's for 1 mole. Look, it's for 1 mole. What if we calculate for 2 moles? So for 2 moles equals to delta H equals to 2 times negative 2811. For 3 moles times 3. For 7 moles times 7. For 1.2 moles times 1.2. What about 30 gram? For 30 gram, delta H will be, okay, you have to calculate for 1 mole as a first step. Then we don't need gram, we have to convert into number of mole. Once you calculate the number of mole, by this, mole equals to mass over molar mass. When you calculate the number of mole, then multiply by your result. For 2 moles times 2. We have a wonderful relation between delta HC and delta H for the reaction. Delta H equals to delta HC times number of mole. So most of the time they are equal because of we will combust 1 mole as a standard combustion reaction. That's why they are equal, okay, if 1 mole of substance is combusted. Let's solve this question. Calculate enthalpy of combustion for 1 mole of nitrogen N2 to form NO2 using balanced chemical equation. In this question, we have to calculate delta HC. In order to get the value of delta HC, first step we have to calculate delta H. Then using this equation formula, delta H equals to delta HC times number of mole. So let's write the combustion reaction for N2. N2 plus O2 to producing NO2. Then balance times 2. It must be times 2. Okay. Delta HF for N2, it's 0. For O2, it's 0. Delta HF for NO2, it's 33.2. 33.2 times number of mole, 2. Sum of delta HF for the product minus sum of delta HF for the reactant times number of their mole. Delta H equals to 33.2 times 2 minus 0 because of the total amount energy for the reactant in terms of delta HF will be 0, right? So delta H equals to 66.4 kilojoule. But it's delta H, and we need to substitute value of delta H in here. Look, delta H equals to delta HC times number of mole. How many moles of N2 combusts? 1 mole. Delta H equals to 66.4 equals to delta HC times 1. So they are equal because of 1 mole of substance. 1 mole of the substance is combusted in a given amount of oxygen. Delta HC equals to 66.4 kilojoule per mole. Okay? So this is a relation between delta HC and delta H. If we have to get the value of each of them, the other one must be known or must be calculated as a first step. Actually, the rest, they have same idea. Well, I will talk a little bit about this. Look. According to this reaction, my dear students, if we have a reaction that given by a question itself, so you have to be careful, okay? There will be a trick. Calculate enthalpy for producing 1 mole of iron. Look, first step, you have to calculate enthalpy for this reaction. How many moles of iron produced? 4 moles. But it asks to get the value of delta H for 1 mole of iron. So first step, we have to calculate for 4 moles. Then for 1 mole, you have to divide the result by 4. Okay? You have to divide the result by 4. Look, it's delta H for 4 moles of iron, but for 1 mole, you have to divide by 4. Another question. Look, they are same. Okay, let's solve this one. Look, in a reaction, if enthalpy of enthalpy for the products equals to 658 kilojoule, and enthalpy for the reactant, it means this is H of product. 658. It's H of reactant. Equals to 458 kilojoule. Which of the following is true? Let's get value of delta H. Delta H equals to H for the product minus H for the reactant. Equals to products 658 minus 458 equals to positive 200 kilojoule per mole. So it's delta H. Look, it's positive, so it's indo or exo, it's indo, right? So forget about exo answers. It's wrong, it's wrong. Endothermic. They are true according to endothermic. But what's the difference between these two answers? The first one, product is more stable than the reactant. The second one, reactant is more stable than the product. In endothermic, because of energy will be absorbed in endothermic, that's why, because of energy is absorbed, so product will have higher energy. So product will be less stable. Reactant will be more stable. Reactants is more stable than the product. It's right answer for endothermic, because it will absorb energy, it will go to the higher energy level, so as much as energy increase, stability will be decreased. That's why it's endothermic and reactant is more stable than the product. The last question, calculate, I'm talking about mathematical, it's last question. Calculate the enthalpy for the formation of butane. Look, enthalpy of formation, delta HF. For what? For butane. Look, we have said delta H equals to delta HF for the product times mole minus delta HF for reactant times mole. Okay, so there are two options. Okay, it's possible to have delta HF values as a given and delta H unknown, or if one of them will be unknown, so delta H must be known. Look, calculate delta HF for butane. This time we have to get delta HF for butane, C4H10. So that means we must have delta H, enthalpy of reaction. Well, let's see if we have or not. Delta HC, okay. Delta HF for CO2 we have. First of all, let's write formation of, let's focus on the formation of butane. Look, delta HF for butane. So unknown, it's from right side. So left side must be given. But look, mister, we don't have. We have one delta HC among the delta HF values. We have delta HF for CO2, delta HF for H2O. But what we have to do, what can be done with this delta HC? If we have one delta HC among the delta HF values, so it's useful for two purposes. The first one, reaction. The second one, delta H. Okay, it will be used to write the reaction to get value of delta H. So we have to write combustion for butane because of its delta HC is given. So combustion of butane, it's like this, C4H10 plus O2 equals to CO2 plus H2O. So first step, balance carbon. 4 carbons, 1 carbon times 4. Then hydrogen, we have 10, we have 2 times 5. Then it contains 5 oxygen, it contains 8 oxygen. 8 is 30. 30 oxygens we have as a total for the product's oxygen. And here we have 0, so it will be 30 over 2. Now, then get delta H in this value. So, mister, we have used delta HC. Delta HC, if delta HC for any substance is known, there, and at the same time there's only one delta HC, so you have to write combustion reaction for that substance. Then use the value and convert into delta H. Delta H equals to delta HC times number of mole. Because of 1 mole of butane is combusted, so delta H equals to delta HC. So that means delta H equals to this number again. It times 1 mole is combusted. So negative 2,877, sorry, times 1 delta H equals to negative 2,877 kilojoule. It's delta H. Then we can get delta HF for butane. Look, delta H, another color, black one. Delta H equals to delta HF for the products. Look, delta HF for CO2 times 4 plus delta HF for H2O times 5 minus delta HF for C4H10 times 1 plus 0 for oxygen. Okay? So delta H equals to negative 2,877 equals to delta HF of CO2 is 393.5, negative 393.5 times 4 plus delta HF of H2O, negative 285.8 times 5 minus delta HF of butane, C4H10. Okay, so you just need to use your calculator to get value of delta HF for butane. Okay, it's very, very easy, and it equals to, so delta HF for C4H10, you can manipulate the data, okay, and then use your calculator. You can calculate this man safely with your calculator. I think it's very easy. There's nothing. It's negative 125.4, I think. Yeah, negative 125.4 kilojoule per mole. Yeah, I remember the result because of I see just right now. Okay, so again, I will repeat the idea of a question. Because of we have one delta HC among delta HF values, so use this value to get general equation and delta H value. Okay, when you get delta H, then you can find the unknown, which is delta HF for butane. Hopefully you understand. And if there's more than one delta HC, it will be Hess's law. So we have some multiple choice questions. Let's solve them like this. It's very important, my dear students. Look, in this equation, carbon plus O2 to producing CO2 plus 393 kilojoule. Okay? Delta H equals to negative 393 kilojoule. Look, about this number, this kilojoule, it stands for what? First of all, it's delta H without thinking. If you see this here, or here, or here, or here, or anywhere, it will be delta H. So answer of A is true. Then, about carbon, it is combustion of carbon, and it must be 1 mole. Yeah, it's 1 mole, so it's true. Delta HC also, it's delta HC. Again, about CO2, we have 1 mole of product, and in the reactant we have primary substances. I mean, it's constituent, it's elements, so it's delta HF also. It's reaction of combustion. It's reaction of formation also, so it's true. Right answer, all of them. In this reaction, CaO plus CO2 to producing CaCO3 plus 176 kilojoule, right? This number, as I told you, immediately without thinking, it stands for delta H. Answer of A is true. Then, about delta HC, it's clear to see, to understand, it is not combustion reaction. There is no oxygen. However, it's 1 mole, but it's not oxygen. That's why it's not delta HC. Because of the reaction, it is not combustion reaction. About formation, yeah, it's 1 mole, but here we must have primary elements individually. Calcium alone, carbon alone, oxygen alone. But look, we have compound here, so it's not formation reaction. That's why it is not delta HF. So answer of D, it's wrong also. Right answer is A, with delta H equals to negative 176 kilojoule. Okay? بمشي كوتاي من بدوزينوي دلتا H هنا بهوي دلتا HF. رجعي دوم كدميني بيدالين هيسس لو. إن شاء الله أويش لەوانەیەکی تایبەت لە خزمەتتان دەبم و لە بۆتان شیکار دەکەم بە ژێرەی توانە. تاو کات هەر شاد و سەرفراز بن، خواتان لەگەڵ.